So this is the first video on nomenclature in organic chemistry, and we're going to start with a fairly simple version of this nomenclature dealing with compounds known as alkanes. And the whole point is this nomenclature doesn't change for the most part. So we learn the basics first, and then we apply that to a whole variety of different organic families. The nomenclature is fundamentally the same. We just end up changing the ending when we get a different chemical family. So it'll take a little while to get through this video, but once we've got through this one, we know the nomenclature for the rest of the organic families. So if we remind ourselves what nomenclature means, nomenclature is this idea of a systematic way to arrive at unique names or formulae for compounds. And we've already seen nomenclature in the context of inorganic compounds, specifically ionic and covalent compounds. Well, now we're going to apply this systematic way of naming things to organic molecules. And just one thing to draw your attention, if you're looking for a slightly different take on this, that is text version, but is not necessarily a really good way to go through nomenclature, you can look at this particular website right here, and that website, there it is. And so this website goes through a lot of the nomenclature I'm going to go through. You can look at all, there's some prefixes, all the stuff we're going to go through. Very extensive website, so if you feel so inclined, you can go have a look there. Anyways, why don't we get stuck into the nomenclature now. So, first of all, what's in a name? Well, there's a lot in a name. So there's a name of a molecule. From this name, I can come up with the structure for this molecule, and I do that by looking at this part, hexane, and from hexane I get that there are 6 carbons. So there's my 6 carbons, and they're all single bonded. That's what the A and E tells me. There is a methyl group on carbon 3, so I'm going to counter 1, 2, 3. There's carbon 3. I'm going to draw a methyl group, and that's what a methyl group looks like. On carbon 3, there's also an ethyl group, so I'm going to draw an ethyl group on carbon 3, and that's what an ethyl group is. Now I'm going to attach a bunch of hydrogens. And there is my structural diagram for 3-ethyl 3-methylhexane. What's a picture worth? Well, a picture, as they say, is worth 1,000 words. Well, maybe not 1,000, but this picture is certainly worth 1 word, and that 1 word is going to be, well, again, what do I have to do? I can count carbons. 1, 2, 3, 4, 5, 6, 7. So there's my longest chain. So that's actually a heptane molecule, 7 carbons. And it's heptane because they're all single bonds between the carbons of the chain. And on carbon 2, I have what's known as a methyl group. Well, there's another methyl group. And on carbon 5, there's another methyl group. So I actually have 3 methyl groups. So now I can name that as 2, 2, 5 trimethyl heptane. And so that picture gives me that name. So that's the power of the systematic way of naming compounds. So let's carry on. All right. So we're gonna go through the naming, and there's 3 things I'm going to draw to your attention in naming, and as I said, these apply to a lot of different families, so we want to sort of make sure we get this straight. So first of all, we have these prefixes. So this is going to allow us to name a component of the parent molecule, or as it says here, the longest continuous chain. So one of the things you have to look for is the longest continuous chain, and that's going to give you 2 parts of the name of the molecule. So the prefixes are the first ones that give you the name, and these prefixes are going to include things like meth. So if the longest continuous carbon chain has 1 carbon, the prefix would be meth. If it has 2 carbons, it's eth. If it has 3 carbons, it's prop. 4 carbons, it is bute. 5 carbons, it is penta, or pent, depending. 6 carbons, hex, hept, octa, nona for 9, and deca. Now you've seen those prefixes before, most of those prefixes in inorganic nomenclature. So again, the prefixes give us the length of the longest continuous chain in the molecule. Now the second part in getting our parent molecule is a suffix. So again, we're still dealing with the parent molecule, the longest continuous carbon chain, and there's a suffix that follows the prefix, and these suffixes are what tell us something about the bonding. And so 3 different suffixes. An A&E suffix indicates that the continuous chain is made up of only carbon-carbon single bonds. So carbon-carbon single bonds, the ending's A&E. Well, if it's E&E, it means there's at least one carbon-carbon double bond. And if the ending is Y-N-E, it means there's at least one carbon-carbon triple bond. And so with the prefix, something like eth, and with the suffix like -ene, we get ethene. And what ethene is a 2-carbon hydrocarbon with a carbon-carbon double bond. So the suffixes combined with the prefixes give us the name for the longest continuous carbon chain. And the other thing we have to deal with are branches. And so a branch is made up of a certain number of carbons. So if we look here, I'm going to look at my longest continuous branch, and that longest continuous branch I could say is this branch. So there is this a 3-carbon branch, which makes this a branch. Okay, so my longest continuous chain is 3 carbons, and this is not part of that branch or chain, so it must be a branch. And so I have to be able to deal with that branch. And the dealing with the branch is pretty straightforward. Just a few things to point out. The prefixes for the branches are based on the number of carbons. So that's a 1-carbon branch, so that's a meth branch. And we give this YL ending, so it's methyl. And here's the reason it's a methyl. That we can't call it a methane because that's methane, CH4. So a methyl branch is CH3, and it has a bond which goes to another carbon. So that's why it's a branch. So there's the bond I've shown there. There it is. The bond attaches to the main chain. So an alkyl branch always has one less hydrogen than the alkane. Okay, so prefixes based on the number of carbons. The position of the branch or branches has to be indicated with a number. Okay, now in this case it is an exception, but I could indicate that with a number, and that's carbon 1, 2, 3. So on carbon 2 I have a branch, so that would end up being a 2-methyl branch. There's some times when you don't have to worry about that. We'll get into that later. The branch position must be minimized. It doesn't show up this way. If I numbered from the other end, it's still on carbon 2. So it is minimized. But again, you'll see examples where we have to order in a certain way to minimize the position of the branch. Multiple branches of the same length, given further prefixes, di, tri, etc. You saw that in the earlier example where we had a trimethyl because there is 3 methyl branches. And in terms of the final name, the different length branches are ordered alphabetically, not numerically. And finally, just to draw your attention to this aspect of organic nomenclature is often one of the things people find most complicating. So it really does require a bit of practice. Alright, there's the summary. Branch prefix. So if you have branches, they're going to have a prefix, and it's an alkyl branch. The prefix indicates the number of carbons in the branch. You're going to have a prefix and a suffix for the parent molecule. So again, this is the main chain or parent, longest chain. And so you have 2 components. That the prefix indicates the number of carbons, the suffix indicates the type of bonding. So again, if we go back to this example we saw earlier, we can now kind of put it all together. So identify the longest continuous chain, because that's going to give you this prefix. So the longest continuous chain, 1, 2, 3, 4, 5, 6, 7. So that's a 7-carbon chain. So that's a hept. It's all carbon-carbon single bonding in that chain, so it's heptane. Now identify the branches. I have a branch there in carbon 2, branch in carbon 2, and a branch on carbon 5. So that becomes 2,2,5 trimethyl. And so there we go. We saw that earlier. There it is again, 2,2,5 trimethylheptane. And that's using this systematic way of putting it together. Practice makes perfect, right? So learn the system by practicing. So here's some practice. Propane. Well, ane, it's all carbon-carbon single bonding. And a prop means 3 times carbon. So it's 1, 2, 3. We're going to just use a condensed structural diagram. So 3 carbons. Add the associated hydrogens to satisfy the bonding. So we can have 2 hydrogens to this carbon because it has 2 carbons bonded to it. The terminal carbons have 3. 3-ethyl 2,4-dimethylhexane. And so I sometimes start from the back. Get the main chain drawn first. Hexane, 1, 2, 3, 4, 5, 6. On carbon 3, 1, 2, 3, I have an ethyl branch, 2 carbon branch. On carbon 2, I have a methyl branch, and on carbon 4, I have a methyl branch. Now you can draw in the hydrogens. H3, 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 H3. Any terminal carbon with a single bonded to the next carbon is going to have 3 hydrogens. Interior carbons mostly have 2. It depends what's bonded here, though. This one has 3 carbons bonded to it, so it's only going to have 1. This one has 3 carbons bonded to it, it's only going to have 1, and carbon 2 is only going to have 1. So there you go, 3-ethyl 2,4-dimethylhexane. Draw what you see. The name gives you all the information you need. Name these ones. Again, practice. So to name it, you have to identify the longest chain still. So this one looks a little oddball, but let's look at the longest chain. 1, 2, 3, 4. If I numbered any other way, I'm going to get 4, so that works. I have 2 branches, and I want to minimize position. So if I started numbering from here, those branches would be in carbon 3. So I have started from the right direction because I've minimized branch position. So what I have is a 4 carbon single bonding, that's butane, and on carbon 2 I have a methyl branch, and on carbon 2 I have a methyl branch. So 2, 2 dimethyl. So 2, 2 dimethyl butane. How about this one? Start by getting the longest continuous chain. So if I, for example, did it from here, 1, 2, 3, 4, 5, and called that an ethyl branch, you have a 5 carbon chain. But if I number from here, 1, 2, 3, 4, 5, 6, I get a longer branch. So that is my main chain, and that happened to be hexane because it's 6 carbons. And on carbon 3, I have my methyl branch, so it's 3 methyl hexane. Okay, so you have to be careful in terms of picking the longest chain, so it might require you to count a couple times. Lastly, draw then name. So here are these structural formulae. So I have CH3, CH2, 4. So I have 4 carbons in the middle and another CH3. So that's a 6 carbon. 1, 2, 3, 4, 5, 6. Saturate with hydrogens. So I'm going to bond the appropriate amount of hydrogens to each carbon. So that's a 6 carbon hydrocarbon, so that's simply hexane. There's no branches, so it's hexane. How about this one? So 1, 2, 3, 3 carbons. Then I have in brackets this branch attached. So this branch is attached to this carbon. So on carbon 3 I have a branch, and then I have 2 more carbons. So I have a 5 carbon longest chain. So the parent chain is 5 carbons, and on carbon 3 I have an ethyl branch. And that's what CH2, CH3 is. That's an ethyl. So now I can attach the hydrogens. That's 2, not 3. So I got to be careful. H2, single hydrogen on carbon 3, H2, H3. And so what is that called? Well, that is called 1, 2, 3. So 3 ethyl. 1, 2, 3, 4, 5 pentane. So like I said, you need to learn the system by practice. So things you have to be able to do. You have to see a name for a molecule and be able to draw it. You have to be able to take a drawing and properly name it. And you should be able to, like we just did here, take structural formulas and be able to both draw and name them. And just a reminder, that nice little website if you want to get a bit more detail on some of this naming. But I think we've covered most of it here. So that concludes this video.